Good afternoon, students. In this lecture, I am going to discuss about capacitors. So first of all, I will give the definition of a capacitor. It is nothing but an electrical equipment, or we can simply say an electrical component. It is not an equipment, just a component which is used in several equipments, and it is nothing but a capacitor is a system of two conductors separated by an insulator. This is the definition for capacitor. You can see it is nothing but a system of two conductors and they are separated by an insulator. Please keep in mind all these words. It is nothing but a system of two conductors separated by an insulator. Okay, let us consider a case. Let us take two conductors, because for any capacitor you need two conductors. Okay, so let us take a conductor of any shape. This is my conductor 1, and this is my second conductor 2. Conductor means which can conduct electricity or charges can easily move. That is called a conductor. You already know. Okay, now in capacitor it is nothing but a system of two conductors separated by an insulator. So you can see there is one conductor here, another conductor is here, and in between you can see air is there. Air means it is an insulator. Okay, it is actually a dielectric. So in between conductor 1 and conductor 2 some air is filled. Instead of air you can fill some other dielectric materials also. Air is also a dielectric material. Other than air you can fill some other material also here. Depends upon the material you are filling, the capacitor name will change. Okay, so for simplicity let us consider the case of air. So two plates are there, conductor 1 and conductor 2, two metallic plates let us assume, and in between there is an insulator, or another way we can say that there is a dielectric air. Okay, dielectric in the sense that electric field effects will be there in air. Already we discussed what is meant by a dielectric. Okay, now let us charge these conductors simply by connecting them to a battery. One terminal of the battery you will connect it to conductor 1, another terminal you will connect to the conductor 2. If you connect, let us imagine that you are charging the first conductor with positive charges and the second conductor with negative charges. Positive means electrons are moving out, negative means excess electrons are there. That is the simple meaning. I already discussed in the first few lectures itself what is positive charge and what is negative charge. So let us imagine that your first conductor is charged with the positive charges and the second one is charged with the negative charges. So first conductor a total plus q charge is there. We can imagine that it is having total q charges which are positive, so positive q charge. And the second conductor, let us imagine that minus q charges are there. Okay, when you are giving some amount of charges to a conductor or any system, it will have a potential. So let us say that V1 is the potential of conductor 1 and V2 is the potential of conductor 2. Now V1 and V2 are different because charges are different. So there will be a potential difference, which is nothing but the difference in potential, isn't it? So the potential difference in this case potential difference between the conductors V is equal to V1 minus V2, isn't it? V is equal to V1 minus V2, and due to this potential difference, charges will flow from one plate to another plate, because you know that when there is a potential difference, charge will move from high potential to low potential region. Hence, since there is a potential difference of V1 minus V2, charges will move from one conductor to another conductor. In this case, it will move from negative plate to the positive plate, okay, so that there will be flow of charges, isn't it? Now, if such a process happens, charges are actually moving because of the potential difference, isn't it? That means if potential difference between the plates are bigger in magnitude, then the amount of charges leaving one plate and reaching the other plate will also be more, isn't it? That means the amount of charge reaching on a plate, if some 10 electrons are moving from one plate to other plate, the plate which lost electrons will become positive, and the plate in which electrons are reaching will become negative. So both the plates become charged, isn't it? So if more electrons leave the plate, then it will become more positive, and thus in the same case more electrons will reach the other plate, so it will become more negative. That means if more charges leave one plate, then both the plates will become more charged. So this leaving charges from a plate or conductor depends upon the potential you are applying, or the potential between the plates. So the amount of charges leaving or moving is proportional to the potential difference V, isn't it? And by multiplying with a constant, you can change the proportionality sign. Q is equal to CV, where C is called a capacitance. Depends upon the material, C will change. For a particular material, C will be same. So if you increase the potential, then the amount of charges on the plates also increases. By using this formula, you can find the amount of charges. If you know C, if you know V, you can find Q. Okay, from this you can define C. C is equal to Q by V. Okay, what is V? Potential difference. Let us imagine if V is equal to 1 volt, if potential difference is 1 volt, that means you are having two plates and you are connecting it to a battery of 1 volt. Then your C will be equal to Q, isn't it? C will be equal to Q. So from this you can define C, capacitance of a conductor. Capacitance of a conductor is numerically, only numerically you can say, numerically equal to charge required to raise potential by 1 volt, isn't it? Because when V is 1 volt, C is equal to Q. From that you can define capacitance as the amount of charge required to raise potential by 1 volt. How much charge you need to raise the potential of the plates by 1 volt? That will be equal to C, capacitance. That means the potential between plate 1 and plate 2. Okay. Now let us find the unit and dimension of SI unit is farad. We will denote it by capital F. Okay, 1 farad you want to find. Okay, so let us take the definition. C is equal to Q by V. If Q charge is 1 coulomb, then if V is 1 volt, 1 by 1 you will get 1 farad. C will be 1 farad, isn't it? So 1 farad can be defined as if 1 coulomb of charge on the capacitor raises its potential by 1 volt, then its capacitance is said to be 1 farad. This is the definition for 1 farad. Okay, this is the SI unit, and some small units are there which are microfarad, then nanofarad, picofarad, etc. Okay, and you can convert it. 1 microfarad is equal to 10 raised to minus 6 farad. 1 nanofarad is equal to 10 raised to minus 9 farad. Like that you can convert. 1 picofarad will be equal to 10 raised to minus 12 farad. These are conversion formulas. Now dimension. We have C is equal to Q by V, isn't it? C is equal to Q by V, and at the same time we discussed that V is equal to W by Q, isn't it? While explaining about potential, we used this equation, V is equal to W by Q. Now you can substitute for V, Q by V is equal to W by Q. So this Q will come in the numerator, it will become Q square by W, isn't it? Now for current, I is equal to Q by T, which we will discuss in the next chapter. Current is equal to total charge divided by total time, from which Q is equal to IT, where I is the current, Q is the charge, and T is the time. Okay, so Q is equal to IT. Let us take it as Q square itself. Then Q is equal to IT. So Q square means I square T square divided by W. Okay, now I square means I is current. Dimension of current is same as the symbol I. Okay, then T, time dimension is T. Okay, so those letters are same, so dimension will be I square T square, because their dimension is same as the symbol. Now work dimension you already know from 11th, it is ml square T raised to minus 2. You can verify it by multiplying force with displacement. You will get this ml square T raised to minus 2. So if you simplify this, you will get m raised to minus 1, because m is in the denominator, L raised to minus 2 t raised to 4 a square. This will be the dimension of C. Okay, now let us discuss one more thing: factors depending on capacitance. There are several factors which will change the capacitance of a material, and they are: first one, shape of the conductor. Depends upon the shape, capacitance will change, and we will discuss in the next lecture the capacitance in different shapes. Now second one, dimension of the capacitor or conductor. We can say conductor. That means the area, length, etc. They are the dimensions. Now nature of the medium, that is the medium in between the plates. There are two conductors, so what will be the medium in between the plates? That also depends on the capacitance. Okay, now these three we will discuss in detail in our next lectures. Now symbol for capacitor. We will represent capacitor by using two same size lines and two lines like this. This is the symbol for capacitor. In a circuit, if you want to represent capacitor, you will represent it like this: two lines. Then this is battery. You already know this is the symbol for battery. So in this diagram, you are actually connecting a capacitor to a battery. Capacitor symbol is two same sized lines connected with straight lines. Okay, now in the next lecture I will discuss the capacitance of different types of conductors based on their shape, because in this lecture I explained that when shape of the conductor changes, capacitance will change. So in the next lecture I will discuss different shapes of capacitors and their capacitance. Okay, so basically we explained capacitor. It is nothing but a system of two conductors separated by an insulator, and it is used to store charges. This is the basic definition for capacitor. It is a system of two conductors separated by an insulator, and it is used to store electric charges. If you store electric charges, you are actually storing electric energy in the form of charges. And we discussed this one equation also: C is equal to Q by V. From that we explained what is C, then we explained the units and dimensions of C, and we defined farad. Then factors depends upon this capacitance. Capacitor is a device, whereas capacitance is the property of a capacitor. And finally we discussed the symbol also. Now in the next lecture I will discuss the factors which depends on the capacitance, especially shape. Depends upon the shape how the capacitance changes, will have some derivations.